Right, good afternoon, ladies and gentlemen, and welcome to the Radio Society of Harrow. This afternoon we have Matthew Smith, M0VWS, who's going to give us a talk on basic shack construction. Over to you.
Thank you. It's just to go through some of the, if you like, some of the simpler points of constructing your ham radio shack, your amateur radio shack, and some best practices, what to do, what not to do, that sort of thing. So yes, it's pretty straightforward. My name's Matt Smith. I'm M0VWS or DJ0DJS as also known. And I currently am with Martin Lynch and Sons. I'm sure you've probably heard of the store or visited the store at some point. If you haven't, you should do, because the coffee's free and the radios are always on sale. So don't forget to pass by. We're in the Staines upon Thames area of West London. Can everybody hear me okay, by the way? Is that all right? Yeah, you can? Okay, all right there, good, super, thank you. So previously I was Radcom technical editor for a while and done quite a career in aviation, electronics and that sort of thing. So this talk basically is straightforward. Hello there. Very again, you know, it's the fundamentals of things to do with your ham shack and what to do, what not to do, etc. Well, that's working as well. There we are. That's good. Talk contents. Simply, there we have a typical shack, and the talk contents. We've got shack design. It's very straightforward. Things to consider when putting together a simple ham radio shack. So, grounding and earthing, obviously. Power supplies for amateur radio use. Antennas and antenna feed lines or transmission lines. Audio paths, and obviously lastly, and by far the least important, what sort of radio you actually use in the shack. We just go through these different points. Again, if you've got any questions at any time, just raise your hand, you know, shout out the questions. Don't worry, I don't want to save everything to the end in a question answer, you know, period, because sometimes if it's in your head at that time, you want to put it out. So grounding and earthing. The most commonly misunderstood part of electronics and electrical systems, and this is really part of that fundamental thing, is that grounding essentially is one of the most important parts of your ham shack, but it's often the most overlooked. In many cases, people will install very high quality cabling and very high quality power cables, audio cables, etc., but they don't put so much importance on grounding. And grounding actually is quite if you like, it's the number one thing really that you should think about. There are two different types of grounding. Undergrounding, insufficient level of grounding, which causes noise and operational issues. There's one more. Hello, sir. Are you all right? Undergrounding's not something you really, of the two, should be erring on that side. We'll come back to that, but possible or dangerous level of grounding is another issue. These are coming back to that. Overgrounding, this is everything connected to everything. The table in front of me is a good example. Although that isn't really everything connected to everything, there's a lot of wires in one space. High current levels flowing in ground systems, ground loops and audio issues, they're most common amongst faults with your setup of your ham radio shack. And if you think, what's going on, why is it making that noise, what's happening here, why is that doing odd things, usually it's to do with grounding or what's going on with the grounding. Causing issues, not fixing them with grounding. So if you're overgrounding things, if you're connecting the case of one unit to the case of another to the case of another, and then that's connected to one unit which has got USB plug on it, and that USB goes to the PC, and the PC's plugged in one main socket, and over the other side of the house you're using another main socket, and that one runs an earth round this side, and that goes into an extension cable, so on and so on and so on. And everything seems to be connected to everything. Well, that's overgrounding. Now, there's a little thing there called ground looping, or making ground loops, or localized antennas. So the noise and the interference that you might get, that might come from overgrounding. More grounding equals less noise. Well, that's not always the case. Sometimes overgrounding pieces of equipment or incorrectly grounding equipment can introduce noise into your shack or into your audio systems and perhaps your microphone systems, your mixer, if you use that sort of stuff, you might find that grounding actually causes noise rather than prevents it. But there are different things there. Ground loops, now they're something which are probably not considered by most amateur radio people. Amateur radio is amateur at the end of the day, and we experiment with lots of different things, plugging stuff together and seeing what works and what doesn't. But I could tell you just on that table there are probably 4 or 5 ground loops going on between the projector, the mixer, the microphone, the power units, etc., etc. And some of those there are isolated transformer power supplies, and some are not. So there may well be ground loops there. Ground loops can cause noise in your shack. They work like antennas in the local environment, and that's something to be aware of course. And also, I've put there accidentally damaged equipment, and you may think, how can I damage something by grounding something? Well, you would be surprised how many radios that I repair where the USB interface has been completely destroyed because it's been connected through another piece of equipment which has only got, for example, a 2-pin power connector, and the radio may well be earthed through either its antenna system or it may well be earthed through its power system. And we often do a lot of work on repairing equipment which has been damaged by overgrounding. And of course, the other part of that is undergrounding. There's a clear safety risk with mains powered AC driven equipment that if you don't ground correctly, you could find yourself in a bad situation. Risk of personal injury, risk of damage to equipment, personal safety issues like working alone, for example. A lot of us do sit in the shack alone. If you are, or if you do rather encounter some form of electrical shock, if you're alone, it could be an issue. So then damage to equipment through unknown ground paths, that's what I was just talking about there. So that's where grounding, essentially currents flow in ground systems which are unexpected. That happens a lot with USB powered equipment, especially USB powered equipment such as small SDR receivers that have metal cases, and you connect those to the PC, and the other side of it's connected to your antenna system, and that antenna system is also additionally grounded but via another path. And of course, risk of introducing noise into audio lines if you don't ground the audio lines, not separately from your power grounds, but in the correct way. So that's just something to think about, the differences between sort of the two different ground systems, or not the two different ground systems, but overgrounding equipment and not grounding it enough. Then again, now this is something which is a kind of mission statement, but it's not. It's also not. Certain types of amateur or certain types of radio antennas or their feed lines require a connection to ground. Since the frequencies used in ham radio antennas are far higher than the 50 or 60 Hz frequency of the power line, ham radio grounding systems use different principles from AC power grounding. The protective earth, or PE, in safety ground cables or in AC building wires, they're not designed for and cannot be used for this purpose, i.e. they can't be used for grounding your antenna system. The long utility wires, for example, from that socket all the way around the building through to that socket and all the way up to the distribution board, they have a high impedance at these frequencies. And within the case of sort of an RF transmitter, the RF currents flowing through the ground wires can radiate radio frequency interference and induce hazardous voltages on the grounding or the grounded of other metal parts or other appliances. So separate ground systems are used. And this is the difference between essentially the earth pin in your 240 volt, 230 volt AC system and either your shack earth or your antenna earth, or maybe some of you who are lucky enough to have a tower will have an earth off of the metal tower which has got its own grounding system. Maybe it's a kind of copper rod that's driven into the floor a few feet, or maybe it's a mesh, a mat that sits underground and is connected to the tower. Well, they're different sorts of grounds, and it's important to distinguish between those grounds. Mains grounding and electrical safety. Now, well, okay, I'm not going to go too much into the electrical safety parts of it, because obviously that's a very complicated and a very, it's not really, it is related to amateur radio, but it's also here. I'm just trying to point out, so items with electrical or metal cases, this is mains powered that essentially should have a 3-pin connection but with a metal earth pin. Now I've seen recently a lot of, I'm not sure if they're predominantly imports, but I've seen a lot of equipments that come through with power cables and they have a plastic earth pin, which simply is just there to lift the two little neutral and main slots in your socket. But it has a plastic earth pin. And I've seen some equipments, it happens more in the computer market, I must say, rather than amateur radio. But metal cased items which actually come with a cable like this, do not use that cable. Use your own cable, put your own plug on if you're able to. It is important. Try and avoid using those 2-pin plugs. And of course, I've put there, do not rely on your antenna's RF earth for your mains electrical equipment. The number one earth you should use when it comes to all of your shack equipment is your standard PE earth from your main system. Antenna grounding is something else we can discuss afterwards, but ensure the grounding is good in metal cased items like your PC, for example. Most PCs use metal cases these days. Ensure that always uses the correct fuse rating and has a brass earth pin, because it's quite important, that one there. So that sort of brings me on to another subject, which is shack power, mains and DC. Well, power systems for amateur radio use, of course, there are many different types of radios. There are many different types of power supplies. Some radios obviously are mains powered, some are powered with your 12, 13 volt DC supply. A lot of us, and myself including, will use mobile radio at home. So you can't connect that, even though some of our customers have tried, you can't connect that to mains directly. It does happen. One gentleman, what did he do? There was a big, it was an ICOM, I think, and it had a large power filter in the
7300.
Was it a 7300, Mark? Yeah, and it had a large power filter in the DC cable, and that was what confused by one customer with an actual power supply, so that got connected to the mains, and that didn't work afterwards, funnily enough. So yes, mains power supplies. This is actually quite an important subject. I've split them into two different groups because, and those are linear or transformer based and switch mode. This is quite an important subject because a lot of the time I find that if something is not functioning as it should be, 90% of the time it's the power supply used to drive it. And that is the case whether it's a radio or whether it's even just a small, sort of plug-in transformer power supply. there are a lot of items which I look at that have been damaged because the wrong power supply has been used. Unfortunately, that text is a little bit small there, but linear power supplies are power supplies essentially which use transformers. So the mains power is isolated from the secondary power. And I'm going to assume that everybody here understands what I mean when I say transformers, in that the mains AC is transformed down to, say, maybe 13 volts AC and then rectified into DC. And I assume, go ahead.
Sorry, going back to before about the mains system,
Yeah.
mains power supply, would you expect to see potential difference between the RF earth and the mains earth?
Yes, if the antenna is some fair distance away from the shack, you could see potential difference between them. And of course, it depends on a number of different things to do with the antenna ground. If the antenna ground is in, well, also it depends on how the grounding system of the house is configured. I haven't gone into that subject in detail because these days there are many differences between how a house is grounded, if you like, and what sort of grounding system is used to, in the supply to the house, in the main supply to the house. Typically, older properties will have a localized grounding system.
DNS system.
Yeah, okay, yeah. Then I've seen a lot, or rather more modernly, you'll find that the earthing system is tied in with the neutral system. And it's not earthed actually at the property, it's earthed further down, or further back. There are, well, this is kind of a minefield really. There are many different questions to do with grounding and to do with RF grounding. Now, if you were, this depends how far you take it. If you take your complete shack power system and you fit an isolation transformer between your house supply and your shack AC system, and you keep everything to one side, so this is your shack grounding system and this is your house grounding system. In terms of electrical noise, that would be the best situation. However, it might not, I was going to say I don't recommend it, but in terms of radio, the gains with your radio, the low noise floor, those sort of benefits, that would be ideal. However, you really should make sure that that shack grounding system or that external grounding system that you install is fully functional, in terms that it would support 10 milliamp RCDs or 30 milliamp residual current device, and so that you should have that independently inspected and checked by a qualified electrician. And if they sign that off, then say that that's good, then that's fine. But I wouldn't recommend, a mains power isolation transformer and then ground all of your shack equipment just by connecting it to your antenna lines and then put something underground outside and hope that that works, because it may not. And of course, it's very important that you make sure that the grounding system is functional. Again, it also depends on, for example, what sort of ground, what sort of soil, where you're grounding. If you've got to go quite some way down into the ground to get a good electrical conductivity. It depends on the soil type, it depends on a number of different things. Yes, there can be sometimes quite a high potential difference between the two.
Is that dangerous?
It is if it's above, say, 30 volts or so, maybe a little bit higher, but this is a difficult subject. I didn't want to discuss too much about electrical safety in terms of grounding, because it's a nice idea to have a mains ground, your own dedicated mains ground for your shack. And if you've got an external building and everything within that external building, so like your typical outdoor shed, for example, is grounded to the RF ground, and it's kept separate from the house, then that's fine. But it must be kept separate. And then in that case, that earthing system needs to be verified as its own entity. But if you don't have that, then rely on the house grounding system and stick with that.
You want both. You want the RF earthing and you want the mains.
Yeah, you can do both. I mean, that wouldn't be a problem. And if you do that, it isn't going to affect the way that your shack works. And having both is not really an issue. And the only reason for actually externally grounding is for noise reasons. But you've got to be really quite high up the tree when it comes to.
One final point.
Yep.
I have a phenomenon. I have an end-fed wire, so I've got a ground earth for that, obviously.
Yep.
See? If although I use mostly a doublet, if I disconnect the RF earth, the noise level in the doublet gets slightly higher.
Yeah. Okay.
Does that sound ominous?
No,
That's
not.
exactly
I mean,
what you'd expect.
yeah,
Yeah. Okay. Thanks.
no problem. So again, switch mode power supplies are a good way to go. Lightweight, obviously, if you're working portable. Very powerful for the size. There's a good range of choice out there when it comes to those, and plenty of choice for the cost, essentially. A lot of them have power pole connectors, which are quite nice for you to use on the back of the power pack. You can just go directly with power poles from those to your radio. You have to be quite careful where you buy and what you buy. A lot of the imports, they're not UKCA or even that's supposed to say CE, sorry, approved. Some can be noisy. Many of the cheaper ones do radiate in the HF spectrum. They have a tendency to have a switching frequency of around 25 kilohertz, and you may find if you use a more modern radio, an SDR radio, you'll see that in your band scope, and it's quite irritating because it raises the noise floor, and if you're listening for weak signal DX, you'll find that your power supply noise is creating a noise floor that's higher than the signal you want to listen to. Usually they're okay HF and UHF use because the fundamentals of the switching are lower than say 144 megahertz. A good quality one will have power factor correction, which is another interesting point. So switch mode power supplies, that's one way to go. Now, of course, DC systems for amateur use. Okay, so this is an interesting sort of thing. Hello, hi, no problem. So typically, your radio, or any radio for that matter, it's got a certain power conversion efficiency. So don't expect your 100-watt transceiver to be able to function correctly if you don't provide it with the correct amount of DC power. And this is sort of to do with the power supply, but it's also to do with the interconnecting cable between the power supply and the radio. A lot of time somebody will send me a radio back and say, this just doesn't work. It only makes 55, 60 watts on my power meter. Okay. And then you look at the power cable and they've lost the original power cable and substituted it with a bit of bell wire between the two, and it's just not good enough. And they say, but it measures 12 volts at the radio. Well, it does measure 12 volts, but without any load. So, and then of course, as soon as they start transmitting with digital modes that require continuous carrier, you'll find that voltage drops right off and the radio can hardly work at all. Most, nearly all, have a carbon power conversion rate, I'd say, of about 50%. So if you're looking for 100 watts of RF out of your radio, you'll need to provide the radio with at least 150 watts or 50% more of DC power. So think about that when you look at the cabling involved at the power supply that you purchase to go with the radio, assuming it's a mobile radio, or maybe it's a base radio that's powered from 12-volt supply. Some obviously are mains powered, have their own internal power supplies, in which case the problem, you don't need to worry about that so much. But this fundamentally is more about powering 12-volt radios and mobile radios in your home shack, and have I got enough DC power to make it work properly? Well, you do need a power supply that is able to provide 150% of what you would expect the radio to transmit. So it's quite important to get a good power supply. And of course, the other thing which has just occurred to me is that if you're only using one radio, but if you're powering 2 or 3 radios from the same power supply, you would need to uprate the power supply even more. Especially if one radio is perhaps beaconing or transmitting or working on APRS, and it's sending automatically, and that send coincides with your transmission, then, and both radios transmit at the same time, then the DC load is doubled on the power supply. So it's important to think about what sort of power supply you should use. Antennas and antenna transmission lines. Well, it doesn't have additional complex mathematics. I mean, that is not the case. It can, but there is no need to include it. And it isn't this magical thing that people seem to think it is. RF, many believe RF is a form of magic. It's not. It's just science and maths, and that's all it is. Although, yeah, we've all heard the stories, and yeah, sometimes it can be a little bit confusing. Well, a little bit of luck on bad days also. It's clear that antennas, just like any other electrical system, have a mathematical side to both their construction and use. It's just plain physics. We don't, as amateurs, need to have degrees in mathematics to be able to make or use a good antenna. And that's the thing, we don't. The simple dipole is a great example. The antenna theory is quite straightforward, but what's more important is the antenna transmission line, or the coax run, for example, or perhaps it's ladder line. Hello. And that's an interesting point, because, I mean, how many people here make their own antennas? Does everybody construct? Yeah, okay, that's nearly, yeah, okay, way more than 50%. Making their own antennas. Now, I would always recommend making your own antennas. It's great fun to do. It gets you outside, and you get to actually use something you've constructed yourself. And in amateur radio, there's nothing better than that. But it's not important to be able to understand the real detailed mathematics behind antennas. Very, very few people do. In fact, very few people that actually even build antennas on a professional scale really understand the full mathematical theory behind the antennas and the way that radio signals propagate. We don't need to know that, because we're amateurs, and at the end of the day we're going to learn by experimentation. That's pretty much how most of us learn. What we know today is by experiments, and by, if it goes wrong we learn, if it goes right we learn. So it's always good. I mean, I'm sure that for HF, if we're doing HF, everybody's had a go with making or putting up a dipole antenna. It can be quite straightforward. Coax, and then one wire one way, another wire the other way. And we've had good results with that, and it works. And so, it's not necessary, I know, to have such quality, or not really qualified, but maybe you don't need to have this degree in mathematics to be able to build an antenna. Sometimes it's fun just to get out there and try and see what happens. There are a few sort of rules, or a few basics. Keep them away from things. Antennas, like many hams, prefer to be left alone in the garden, and this is true. Keep the antenna as far away from buildings, from trees, from anything metallic as you can. Try if possible to get your antenna as far away from the shack and any other buildings that you can. Losses on transmission lines are negligible in comparison to good antenna position. Well, okay, and so if you are lucky enough to have quite a large garden and you're able to get your antenna away from your house, away from sources of noise that might come from your own house, heating systems, LED lighting, televisions, etc., etc., we've all got them, and they're pretty much on all the time if you live in a family household and you've got children, and you know, things will be on, and all those things will make a certain amount of noise, and the further you can get your antenna away from them, then the better your reception position will be. And of course, losses on transmission lines in terms of our received signal or transmitted, you know, forward power, they're nowhere near as much as the loss of having an antenna that's in a bad position. So if possible, get the antenna out into the open, and we don't all have space for a tower, no, true, or for that matter a neighbour that would accept one. This is okay, as we can still work the world on a wire if we get it right, and this is quite true, but a lot of that statement of course is dependent on conditions. We all know band conditions go up and down on every band. Yes, it's nice to have the perfect antenna system, but it's not absolutely necessary to have fun. That's true. Receiving antennas have slightly different priorities from RX and TX antennas. Okay, so an antenna that's designed specifically for receiving, a different design can be in a different location, and sometimes consider, if it's possible, to have one antenna to transmit and another antenna for receive. And a lot of the, I would say a lot of the more modern radios, any built in the last sort of 20 years or so anyway, usually have more than one antenna socket. And on those, it's, go ahead, yeah? Why have two? Well, because if you, for example, would like to have one antenna that is placed in a very quiet position, so maybe a beverage antenna that runs all the way along the top of the fence, and it's away from your transmit antenna, you can have a very, very long antenna, for example, that works and receives on many different bands. And you can have an antenna for transmitting that maybe you've cut to a specific length. So the antenna for transmitting will be maybe designed to work specifically on the 20 meter band. And it will radiate really well on the 20 meter band. But because it's specifically for the 20 meter band, it might not receive very well on maybe the 50 megahertz 6 meter band. So what I tend to do is, obviously it will receive quite well on 20, and if you're happy with working on one band, then that's fine. But if you can, use the two antenna sockets of the radio, so that for general coverage receive, or if you're looking to receive broadcast stations in shortwave, medium wave, etc., long wave bands, then a different receive antenna on a different connector of the radio. It doesn't have to be complicated, it can be a very, very simple piece of wire. Will often work better for receive. So, but I mean, that's not essential. It's kind of an ideal situation. It doesn't need to be that way for you to be able to work. Transmission lines, again, this is something which is quite underlooked. I know people who buy very expensive antennas, and then they use some of the worst coax I have ever seen, which has been in their garden for 30 years, and it's full of water, and it's got holes in it, and the little animals have been nibbling away at it for years, and but it's fine. They go and then buy an opti-beam and put it on the end of it, but this is very important and yet under-considered part of the amateur radio station, the antenna transmission line. So if you do manage to get enough DC power into the radio to make the radio work to its full potential, what then do you do with that power? Do you push it down a very, very long line of very poor cable? I mean, it's a give and take situation. Why can't anyone hear me? Well, okay, it's all about loss. And unfortunately, in terms of electronics, loss is our enemy in terms of heat, predominantly. But in the amateur Radio Shack, there are many places where we have loss. It's in your DC power cables. It's inside of your radio in terms of the power conversion factor between the amount of DC energy going into the radio and the amount of RF energy coming out for your transmitter, for example. Loss is in your antenna cable and in your actual antenna. And this is where everyone's going to say, no, it can't. My antenna's got a gain of 6 dBi. Okay, so how can it be lossy? Well, okay, we can come back to that. Loss is everywhere. Loss is in all cables, in all cabling systems, and in all pieces of equipment that convert energy from one form to another. It's certainly in the projector here. If we calculate the amount of electrical energy going in and the light energy coming out, there's a loss. It's in the speaker. There's more electrical energy going in than there is sound energy coming out. And there's losses everywhere, and your amateur radio transmitter suffers from exactly the same problem. So think about perhaps your transmission line. Ideally, try to keep it short. Now, hang on a minute. I've just told you to put your antenna as far away from the house as possible, and now I'm telling you to keep your antenna cable as short as possible. So I'm contradicting myself a bit when it comes to those things. Now, well, okay. Putting your antenna into its best possible position is more important than the negligible amount of loss you're going to get if you use good transmission line. Good quality cable, or if you're using balance line, for example, like a ladder line, feeder or something like that. Very good. That is really quite important, because and it's not just important in terms of what you get from your transmitter. It's also, or making best use of what you've got from your transmitter. It's also important in terms of what you receive, your receive level, or your ability to receive weak stations. And if you're into DX stations or long distance contests, for example, you want to be able to receive as much as you can. So transmission lines are quite an important thing to think about. And there we get to a kind of dilemma, really. If you're going to spend £500 on the best radio in the shop, don't. Buy a £250 radio and spend £250 on the antenna and the connecting cable. Now, you'll make more contacts and have more fun, which is the most important part of the hobby, than buying the £500 radio and putting the co-hanger in the tree. Radio to antenna cost ratio should be 50-50. Okay, not 90-10, but ideally 10-90. So what do I mean by that? Well, I mean, okay, what I mean is, if you do have a budget, we all have a budget, let's face it, there's absolutely no sense at all in putting 90% of your budget into the radio that you buy, and then 10% into your antenna transmission line, connection line, and your actual antenna. The most important fundamental thing about your amateur radio station is your antenna. It's not what radio you use. It's not what kind of microphone system or mixing desk or computer you've got. Those things are all really immaterial when compared to your antenna, the importance of your antenna to your station. Your antenna is your station. The rest of the stuff are just things that allow you access to your antenna. Now, yeah, okay, 50-50 would be a good ratio. to do, but certainly don't, if you had £100, spend 90 of it on the radio and 10 on the cables that connect it to the antenna and the antenna itself. Do find that I have many customers who are not happy with the performance of their new 101 MP. And when you start to dig down into their station, you'll find that it's everything else has been completely ignored and forgotten about. Grounding's been ignored and forgotten about, and the antenna is a stretch of wire that's about 2 foot off the ground and runs like this between a concrete building and another concrete building down the side. And, I can't hear anyone, and I can't seem to my SWR is all over the place. Well, yeah, okay, it will be. Think again, more money on the antenna, less on the radio. Of course, it's not just the antenna cable. There are many different parts, audio cables and connections. Another mostly misunderstood subject, microphone connections. Well, okay. Single-ended versus balanced line, which I use and what's compatible with my radio. Does buying a better microphone help? What sort of microphone would you buy if you were to change the microphone of your radio? And then there's mic impedance. Is it right for the radio? I've seen so many situations where microphone upgrades have been applied to the station, and well, customer says, well, it's no better. In fact, it's worse. It doesn't sound as good as the stock microphone. The basic Kenwood Fist mic, I didn't have any problems. I got good audio reports, but I've just upgraded to the latest Heil system, and it's just not working. Yeah. Well, there are a number of different things going on there. One, the more complicated you make the shack, obviously, the more you need to understand about the way you connect things together. Think about the audio bandwidth and frequency response. Typically, we're going to work maybe FM, AM, and SSB on HF, excluding digital modes and audio connections via USB between PC and radio, okay? Because that's a whole different ballgame. But if we're going to transmit using SSB, well, okay, what's going to be our transmission bandwidth? Maybe 2.5 kilohertz, maybe 2.8 kilohertz, 3 at the most, I would have thought. Some people use more. Shouldn't really use more than 3, but if that's the case, if I've only got a transmission bandwidth, let's say of 2.5 kilohertz, why do I need a microphone that has a frequency response of 20 hertz to 20,000 hertz or 20 kilohertz? Why would I use a studio quality microphone with a very wide bandwidth if the only portion of it that I'm actually going to send from my transmitter has a maximum of 2.5, 3 kilohertz? Go ahead, sir.
There is a G3 I hear occasionally on HF.
Yeah.
Who is a retired sound engineer, and he's put together a fantastic system with a studio mic and really good equalisation. So he obviously knows what he's doing. But his SSB is astounding. It sounds like broadcast quality. So I'd like to know more about how he achieves that.
Yeah, okay, yeah, sure, yeah.
Could I,
Yeah.
Can
Yeah.
I put a compressor, basically?
Yeah.
Vocal fan compressors, either digital or kind of.
Yep. Absolutely, that's an option, yes, for sure, yeah. Yeah, there are many different things you can do, but it gets quite complicated. If we're talking about here in this situation, a radio that doesn't have, or how you haven't enabled, for example, any kind of transmitter audio equalization within the radio. So we're talking about stock radio, so IC7300, IC7200, FT897, something that doesn't have any audio bandwidth or any microphone equalization built in. Then your typical transmission bandwidth on SSB would be 2.4 kilohertz. You can use audio accessories to change the bandwidth of your audio response, but it's about manipulating the various different parts. If we were to split that 2.4 kilohertz into different sections, it's about manipulating those different sections to enable the best articulation in what we hear. And what I mean when I say this is, if we're looking at an audio response or that's for the communication purposes, take a Motorola PMR system, VHF analog. It's just to really concentrate only on the parts of the voice that are needed or required to get information through, to pass a message from one radio station to another. Now that's very different to what the gentleman there was just saying about your G3 station, where maybe the gentleman has concentrated more on producing a better sounding transmission across a wider bandwidth with more information in it, because as the bandwidth gets wider it contains more information. But don't forget, if you widen the transmission bandwidth,
The filters will cut it out.
well, that's a receive, yes, absolutely. On receive, yes, they may well do, but power is only relevant within a specific bandwidth. So if you have a transmission bandwidth of 2.4 kilohertz, for example, and you have a transmitter power of 100 watts and an antenna gain of however it may be, the amount of actual energy that you're putting into that transmission is contained only within that bandwidth. If you're now going to spread that bandwidth out because you want to contain more information, more treble, more mid, more bass, okay, so you want a better sounding transmission, you're going to need to use a wider transmitter bandwidth. But if you still only have the same amount of power, you now distribute that power across a wider bandwidth. So yes, it's nice to have a better sounding transmission if that's what you're looking for from your station, but it might not make you as many contacts.
And that's what he achieved. And most people go to compression, or in the old days we used our Dayton clippers, which were very
Yep. Yes, absolutely. Yeah. Yeah.
But somehow or other this guy's managed to achieve comprehensibility, and maybe that's more important.
But would his station, would he be able to make contacts that say, let's take another station which has quite a narrow bandwidth, where the audio gain's been adjusted or the equalizer has been trimmed so that between, say, 2.8 and 3.5 kilohertz audio frequencies have been pulled up slightly in an EQ, just to give a bit better articulation in the comms side. You might find that, and use the same 100 watts in a narrower transmission bandwidth, you might find that station's able to make contacts further away than or be heard more easily, let's say, in a large pile-up of different stations. Your friend's station, it might well have a very wide audio bandwidth, but it's the MP3 argument. Those lower frequencies and those higher frequencies are not needed to make communication possible. They're there to make things sound good, and it's not important for in terms of communication. It's fun to experiment with, absolutely. It's fun to experiment with, but it's not really something which you, if you're a beginner and you're starting out and you want to learn some shack basics, it's not really the sort of thing that you need to think about. Not at this level, but I mean the audio argument. We could really talk for days about the best way to set up your microphones and your audio and your equalizer settings and your compression and the like, and that's absolutely true. And which of these two configurations sounds best? That's one argument. Which of these two configurations will allow communication in difficult circumstances more easily? Well, the one on the left probably sounds best, but the one on the right works. And it works amongst noise, it works amongst many different things. So it's all about what you actually want your station to do. What do you want to get from your station? Do you just want to communicate? Or do you want to experiment with audio, experiment with your transmitter, and this is obviously excluding any kind of reception filters, or excluding your configuration of your receive. I mean, that's a whole other thing. I'm just talking about transmitted audio. The station on the left there, obviously, you know, as you mentioned, the back compressors. Well, I'm sure one of those is a compressor somewhere along the line. And there's obviously, you know, a 30 band EQ in there, and probably some other bits and pieces, and maybe even a little bit of echo as well. It wouldn't surprise me. But the thing on the right, well, okay, yep, it's got a PTT button, you know, and well, a microphone. That's it. Does it need more? Does it need more to communicate? Well, perhaps. It's something to think about, of course. And the last and most unimportant part of your shack, what radio you use. Now, okay, this is personal, but those two radios are in my shack, and they're my most favourite radios I've ever owned. And some people may actually agree, and some people may disagree. Is it clear that the more money you spend on a radio, the better it will be? Or it's clear, is it? Does everybody agree or not? What do people think about that? The more is it, sorry?
Is that KW kit?
That there?
Yeah.
No. No.
Drake.
No, it's not Drake. No, it's not Ellicraft. I can't remember now. It's no, it's not Collins or Tentec. Helicrafters. It's a Helicrafters, 44 transmitter and 40 receiver, I think. But at that point, I had just replaced the speaker in the front of the power supply, and I was in the process of making a new, recovering the trimming, the fabric on the speaker grill. So it's missing the speaker grill there at the front, and that's a static microphone bench microphone there, which worked quite well actually. It was quite nice, but again, separate transmitter and receiver. Took a long time to refurbish, but worked very well. Everybody has a budget. Stick to that budget. Okay, get what you can afford, and over time trade up. There's nothing worse than putting all of your money into one very expensive radio, not doing the antenna properly, making absolutely no context, thinking this hobby's boring, and going, well, I've had enough of that. Ham radio doesn't work anymore. And that was a waste of that £5,000 I spent on that radio. Well, yeah, that's the thing. It can be like that, but I would recommend start with something small. Start with something uncomplicated. When you get used to that, when you think, okay, great, that's really fully understood, then you can trade up to something else. Radio cost is not directly proportionate to how much fun you'll have, and it's not. I've found that the most simplest radio I've owned has given me the most contacts and some of the best DX, and I've had pretty much every radio out there, and there's not really a direct proportion in terms of the more complex and the better the radio is, that the more stations you're going to work, or the more fun your hobby is going to be. It's not true. So yeah, I mean, something to think about, really. what radio you would use. Now, there's 4 pictures there of 4 different radios. So let's see what you think about these. Now, which one of those 4 radios has the best receiver in it?
The oldest one. The Red Bull one?
Yeah, okay, 2 answers that I wasn't expecting, but correct answers. Absolutely right. The Rockwell Collins 380, top right corner. Very good radio. Which of those radios would you buy if you have never operated a radio before and you just wanted to start out in the hobby?
Bottom right.
Yeah, absolutely. The Kenwood TS50. Very good little radio, straightforward, easy to drive. Anyone can get there, you know.
It doesn't look like 5,000.
No, exactly. That's right. No, that would be the top left. Yeah. But again, that's the 101D or the 101MP, whichever variation you've got of that radio. And yeah, I'm not saying it's a bad radio at all. It's a very good radio, but it's also a very complicated radio, and to get the best in terms of performance out of that radio, you really need to sit down for a long time and read the very large instruction book that comes with it, because yeah, it is quite complicated. And then we move into talking about software-defined radio as well, but we won't go there today. But that is obviously a software-defined radio, and the other 3 are not. I mean, again, my recommendation, of course, start with something like a TS50, and then slightly more complicated. There we've got an ICOM 7200. You start to introduce passband filtering or twin filtering systems where they overlap. That's one of their first radios that has the twin PBT system, and they've stuck with that all the way up to the 7610, which is their current flagship HF radio. And they all use twin passband filtering. That's something which is very useful these days, and of course the 101MP has that. The Collins, the ProMark Collins 380 there, you've got a choice of 8 or 2.2. And that's your filters. Take a pick and have a go. We've taken all 4 of these radios and connected them all to the same antenna at the same day on the same band. And the easiest to operate, I would say, TS50 or the ProMark. Very, very easy. Very simple tuning on the ProMark. You just hit the buttons above the VFO for 10 hertz, 100 hertz, kilohertz, you know, etc. Very simple method of tuning. But the receive performance on that is absolutely staggering. It's outstanding. It really is. That particular radio was bought by one of our customers, brand new in 1979, and I've just repaired it recently and given it back to him, and he's very pleased with it. It's an excellent radio. Yeah, and but you know, first 4 examples really of sort of 4 different types of radio, and you know where you might go. So I mean, that's it really. All I'm just going to say, you know, have fun in what you do. It's a great hobby. It's one of the best hobbies that there is, as far as I'm concerned, and I'm sure you would agree. So if there's any questions, anyone want to pick any questions or anything at all with that, you're welcome.
If you have you talk about noise.
Yeah.
You're using a very long wire,
Yeah.
say 40 meters out from a building. How will the noise influence the wire and the fact that the wire is going away from the source of man-made interference? In other words, will it benefit from the fact that most of the wire is well away from the house, or does the interference start right at the end of a wire?
No, any part of the antenna can pick up noise, but that depends on the source of the noise. But if we're talking about what you've just said, man-made interference, or QRM, for want of a better term, then the ideal situation would be to get all of the antenna as far away as possible, and everything is a compromise. Antennas are a compromise, all antennas, in one way or another. But if you are suffering from noise, it's probably a better idea to try and identify what the source of that noise is, or where that noise comes from, and see if you can stop it at source, rather than trying to move your antenna around until you don't hear that noise anymore. I know that is a lot harder to do than to say. I had one customer who was searching for months for the source of noise, and eventually it turned out to be a solar powered pond pump about 4 houses down. And it was just, we went through all different things, solar systems, electric vehicle chargers, everything,
How did you find it? How did you actually detect it?
We actually detected it by taking a small AM radio, about that big, putting a little loop wire on the top and just walking around.
Fox hunting.
Exactly, yes. You could call it that, yeah. Yeah, fox hunting, noise hunting.
Was it you who gave the talk at the RSGB convention a few years ago, having found one capacitor in a power supply for a kitchen lighting system, and it wiped out the whole area, not just amateur radio?
No, I do know who you mean, who it was, but it wasn't me, no. But
that
it was a
the
colleague of
story
mine.
anyway.
But yeah, absolutely, yeah, that can happen, and
It's the amateurs
and
who
it's-
complained first, and then other people were complaining that they couldn't get FM,
Yep.
no broadcast radio at all.
right, okay, yeah.
Either medium wave or FM. There was just one tiny capacitor missing in that power supply.
Yes, missing or malfunctioning, and this is an issue that we all face, especially those of us who are interested in receiving any weak station signals or working weak power, low power digital modes, for example. A lot of, or the market rather, has been flooded recently, or for a number of years, with power supply equipment which is just really really substandard in terms of the filtering. The EMC regulations are not adhered to. There's very little in the way of noise filtering in those power supplies, and they can be a problem, and usually they are in imported pieces of equipment which have somehow bypassed the UKCA or CE approvals. They have not been tested for EMC. They're not, also they're not, a lot of them are not electrically safe in terms of actually sorry, go.
Well, no, I'm all about this because I've got that problem where I live, got noise and it wipes out
Right.
my radio controlled clocks and what have you.
Okay.
So, meter wave. But I've cheated by using something called CatSync, which is a program. Basically what it does, it picks up your SDRs from Hack Green or 20s or wherever,
Yeah.
and you can tune your radio as you would normally, but the sound's coming out the computer. So
Okay.
40 metres, I would say, alive with everything from all over the place.
Mm.
So I'm listening one morning, a chap in America, Ohio, wherever it is. So I thought, oh well, I'll press the button, BTT, and see what happens. And of course, I'm talking to a chap. I couldn't even hear him, obviously, on my radio, at home, because of the noise in the area.
Yeah.
I'm
Okay.
using
Yeah.
that's up in Cumbria. So I'm transmitting from mine, right, and then I'm receiving from that, because obviously I suppose at Hack Green it's very noise free, maybe.
It is. If you look at Hack Green on their very own website shows you where it is. It is in a very low noise floor area.
I'm tuning 991 like I would normally,
Yeah.
because this CatSync, you pay it, I don't know, £5, £10 or something,
Okay.
and you can then, when you press a BTT, it cuts out the audio of
Yeah.
the Hack Green,
Okay.
and you're transmitting just like you would be using your normal radio.
Oh, I see.
And as you change bands on your radio, it changes on the...
So presumably that's connected to the CAT interface of the radio and converts that to a HTTP protocol which operates the SDR. Yeah, okay, yeah.
The
That's
National Radio
how I've got it.
Oh, okay, yeah, yes.
And you've got
Yeah.
a nice waterfall as well.
Yeah.
Green, so you can tune in nicely.
Okay.
You can move it along, you know. Like, but anyway, that's what I do.
Yeah, that's an
So,
interesting idea,
But
yeah.
what I don't know, which you might know, well, you talked about the noise on receive, okay, you can hardly hear anything or whatever, but when you transmit, the noise is still within your area. So is the transmission being affected by that noise?
Simply no, in a word, no. You will find that noise will not interfere with your transmitted signal unless there is a source of noise that usually comes from within your own shack. So from your unregulated power supply, which is bad, from a noisy switch mode power supply, or from an audio problem, or an audio grounding error, or an audio configuration error, audio levels problem. They're the most common sources of noise. But if it's asking about what noise would be contained within your own transmission, the noises that you hear when you are in receive mode are very uncommonly put into your transmitter, unless, of course, for example, if the noise is a bad switch mode power supply, and that noise, and you can tell that by removing the antenna from your radio, if the noise is still present, then the noise comes from somewhere else, either internally generated inside the radio or from perhaps your power supply. Now, if it was your power supply, then yes, it may well be present in your transmitted audio and your receive audio. But that's probably the only time when you would have both.
General interference in the area wouldn't be going out on the...
It wouldn't, no, not usually, no. Unless, of course, that interference propagates into the audio system of your shack, and then that goes forward out of your transmitter. But
Anyway.
yeah, sorry, yeah, go ahead at the back there.
You mentioned for HF using twin antennas.
Yeah.
Perhaps counterintuitively, I think a lot of people will use a high gain antenna for transmit, and as well as using that antenna for receive, will use a magnetic loop of some kind.
Yep.
That's a very good way of...
Yep, absolutely.
Because
Yep.
of the Q, it's a very good way of filtering out interference.
Yes, absolutely, it is, and that's also true the other way around, because some people prefer to transmit only on one frequency, and they would like to call CQ only on 14250, and they use a loop for transmitting because they never change the frequency, and they just tune it up so that it works perfectly on 14250, and then use other antennas to receive. And this is also, yeah, but absolutely, there's the, loops are a whole other thing, but yeah, why not? I mean, experiment. Why not try a loop for that and a different antenna for something else? It's all about just how much really you want to do and how much you want to experiment and what results you'll find. But different configurations will work better in different situations. So there might be one setup on one station in one part of the country that works very, very well there. And if you take that same configuration and move it somewhere else, it may not work very well. So it's very much about your own situation and your own shack. So
A couple of us a couple of weeks ago visited F6KRK, which is our twin French radio club.
okay.
And we worked on from there. And one thing that the antenna, partly it's accidental, but the dipole that they use on 40 metres is slightly above the metal roof.
Right.
So it radiates vertically, and certainly the UK signal was very strong indeed, wasn't it, Don?
Yes, but I wouldn't have attributed that to a metal roof. It's good conditions on 40 at that time.
Yeah, but we do believe that it is radiating much more vertically.
It might well have, the roof may well work as a ground plane. Sorry, go ahead. Yeah.
I live by a chalk stream river not that far away. I'm just wondering if that will give me any benefit of using that as an earth location.
Well, that's an interesting question, actually. Yeah, and I often hear people talk about working mobile down at the seaside, because they like to use the salt water as a ground plane, and some of the stations there make unbelievable contacts mobile that they say that they could never have made those contacts if they were inland. So there might be something worth thinking about there for using that as a ground. I know that some stations take a ground lead if they do live near a large pond or a stream or water, and they run a ground cable down the length of the stream, as long as they can make it, and connect that to their antenna, grounding. Put it in the water and run it down the stream, and
I used to do this with the river Pin in Pinner.
Oh really? Okay, yeah. And did it make a difference?
Oh, yeah.
Did it work? Yeah, okay,
It
yeah.
was on 160 metres.
Yep. Okay. Yeah. So experiment and see. I mean
I've tried with an end and
Yeah.
and using the river as in my back garden, unfortunately, but it didn't enhance it and made it like just thinking I'm doing something. But it's good to hear anyway. I'll try it another way.
Transport.
Yes, it can work as a ground plane or counterpoise. But you might find that any wire at all that is connected to the grounding system, the antenna, and lays underneath whatever radiating element you use will help. I've gone out with a copper rod mobile and hammered it into the ground of a large field, on a wet day, and just simply taken a fiberglass pole 20 meters high and stood it in the middle, and I've had a perfect VSWR and made contacts all over the place, and an incredibly low noise floor because you're out in the middle of nowhere, and it works very well. And the only counterpoise in that situation was the wet ground underneath the antenna, and that worked perfectly well. But so yes, okay.
Where I live, my house is on an underground stream on one side. It
Yeah.
gives me a very good RF earth.
Okay.
So able to tune anything one for top band right down to about natural VSWR is 1.2 to 1. So
Yeah.
about the middle of the
Yeah.
room.
Yeah,
Down
excellent,
to the
yeah.
stream.
Yeah, you're very lucky. Yeah, it's good. Super. Okay. Well, that's all. Yeah, from me. Yeah.
Okay. A fascinating talk by Matthew. Answered an awful lot of questions. I particularly enjoyed the grounding and earthing section in particular, because that's been a bit of a challenge in my little postage stamp back garden. But thank you also for all the questions, and thank you for
Yeah, no
coming today.
problem.
It's
My
been-
pleasure.
it's been
Yeah,
great.
absolutely.
Can we,
No problem
thank
at all.
Matthew?
Yeah, no problem. Thank you. Thanks.